don't learn it under, we don't categorize those few compounds under organic chemistry, even though it contains carbon. What are those? There are few compounds, even though they are containing carbon, we don't categorize them as organic compounds because we are not learning them as organic compounds. Can you see the screen? Can you tell me while I'm learning, so while I'm listening to you? Very few short compounds. Can you remember? We did those stuff. Carbon, bicarbonates, do they contain carbons, carbonates and bicarbonates? Then why don't we categorize them as organic compounds, carbonates and bicarbonates, and carbon dioxide even, and carbon monoxide? We don't categorize them as organic compounds because they when you look at the structure, when you look at carbon monoxide, when you look at carbon dioxide, and even when you look at carbon, you don't need to learn these things. Like one day you will learn in A levels. Sometimes even in A levels, in Edexcel syllabus, you don't learn this stuff. No need to learn about this. When you look at this, no hydrogen is directly connected to carbon, right? No hydrogen. But all other organic compounds, they are categorizing under organic chemistry. They have a carbon hydrogen bond. Right? So carbon hydrogen bond is necessary to categorize under organic chemistry, but don't write this in the exam, right? These are like kind of more, even the teachers may not know these things, right? So just write carbon dioxide, carbonates, carbon monoxide. We don't categorize them under organic chemistry. You are learning it under only inorganic chemistry, right? What is inorganic chemistry? So I'm going really slow now, right? What is inorganic chemistry? Basically everything, every compound that we are not learning in organic chemistry, we are learning at inorganic chemistry, right? So we are not learning about organic compounds in the inorganic chemistry, right? But still, when you compare organic and inorganic, still the inorganic chemistry is very large, very huge, like an ocean, right? Because when you look around, majority of the stuff are organic compounds, right? So even though, even if you take, let's say there are 136 elements in the periodic table, so we are not talking about compounds containing carbon hydrogen bond, right? So all other compounds not having carbon hydrogen bond is learning at the inorganic chemistry. But still, the vast knowledge of organic chemistry cannot be beaten up with inorganic chemistry, right? If you ask which is more, I would say organic chemistry stuff is more. So you can imagine the importance of carbon, right, for the creation of this universe. And we are not just talking about our your world; we're talking about the whole universe. Right, everywhere in the universe we have organic stuff. Organic means carbon, hydrogen stuff, right? So if there's carbon, hydrogen compounds, there are more likely there's life. So with the current knowledge, maybe later you guys will learn something. Okay, no, you don't necessarily have to be carbon and hydrogen or organic stuff to have life, right? There can be some inorganic forms of life, but still we are not aware of such thing. We are not aware of such a theory yet. This conspiracy theories. So anyways, so right, so back into organic stuff what we are learning in all levels, right? So we are starting off with introduction, right? So introduction, this is where categorizing organic chemistry, inorganic chemistry, and hydrocarbons. right? And then basically we are focusing on the what? Under hydrocarbons, there's an application in hydrocarbon. What is that application? Under hydrocarbons, we are learning an application. What is this application? You must know it now. What is that? Application of organic chemistry. Application means a certain compounds we are learning on the hydrocarbons. There's a huge industry based on that. We are going too far. Right? Crude oil, right? Crude oil. Crude oil. I am asking about what we learn, right? Chemical engineering is there, but not in school, right? Crude oil. After hydrocarbon, we are moving on to crude oil. These are the topics. And then under hydrocarbons, what are those hydrocarbons we are learning? We are learning after two groups. Two groups means what? What are those groups called in organic chemistry? What are these families? Organic families are called as what? Which series? Homologous series. So under hydrocarbons, you are learning about two homologous series under hydrocarbons. What are those two homologous series studied under hydrocarbons? Alkanes and alkenes. See, you know your stuff, right? See, alkanes we are learning and other things alkenes. But anyways, we are learning again about this thing in detail. What's the difference? I just want to know how whether you can remember the stuff, right? What's the difference between alkanes and alkenes? Double saturated and unsaturated, right? Then after that, we are moving on to from hydrocarbons into an organic compound. What is the simplest organic compound we are learning after hydrocarbons? We are starting off with very famous one, right? Famous among men, but right now even among ladies these days. Yeah. After crude oil, what's the other organic compound? Alcohols, right? Alcohol industry. So we are learning right based on the priorities, right? Alcohols. What is an alcohol? Right. Then after alcohols, we are more learning about another organic compound containing oxygen. It has a kind of a property, very useful property. What is that other homologous series we are learning under organic compounds? Alcohol is a homologous series. What is the other homologous series? That's hydrocarbon. Polymers is the structure. It is a structure, right? It's not a homologous series. It's a structure, polymer, right? A long chain, as long as there's a long chain of carbons, it's a polymer. I am talking about a homologous series, right? What's the other one? Only you learned about alkanes, alkenes, and alcohols. Acidic homologous series. Now you should know. This homologous series is an acid. Name ends acids. What are they? Can't remember. COOH, it ends with COOH. Still can't remember. Carboxylic acid, never heard. Carboxylic acid. Right, I'm going to dig it out, right? But your knowledge, right? Then there's one more thing you got to learn. Using carboxylic acid and esters, I show you in a paper also. Using carboxylic acid and alcohol, we can make another organic compound. And it we are learning under homologous. What is that? Combined propanolic is a carbonic acid, oic acid. Using carboxylic acid and alcohols, we are coming up with another Compound, that is compound is another homologous. What is that? I saw it in your paper also. You got one wrong actually. The name. Volatile, giving a good smell. Yeah, it gives a good smell. It's very volatile. What are they? Flowers, they do have this compound. That part gives the smell, the good smell. Esters, never heard? Esters are made out of what? Combining alcohols. So you can't forget it now. It must be forever, right? Very little things you have to learn in organic chemistry. A pinch of salt from the ocean of organic chemistry. Then finally, you told the name. What is the structure? Not all the structure. There are plenty of structures. Synthetic polymers, not only even natural polymers. You are learning about synthetic polymers. What is the difference between a synthetic polymer and natural polymer? Huh? So, okay, natural polymer and synthetic polymer. Natural means naturally occurring polymers. Synthetic means, okay, the main difference is there are slow decaying synthetic. Natural polymers, naturally made polymers. Synthetic polymers means man-made polymers. So you are learning about only man-made polymers. Natural polymers are what? Basically, even proteins, carbohydrates, lipids, those are natural polymers. Synthetic polymers, starting for rubber, synthetic rubber, polythene, basically everything we have, plastics, basically everything we have around, most of the stuff is synthetic polymers. So this is what you are learning, right? Man-made polymers. Man-made polymers. Okay, did you write it down? I need a picture of it. Send it to me. I don't want you to type it. I want to write it. Otherwise, I could have typed it on the screen. In fact, I am the one who's doing the hard thing, writing on the screen. You are writing now. Now writing, huh? So here you can write a small side note. This is how you make notes, right? Introduction means under introduction you are learning about organic chemistry, naming, and you are learning about what? Structures, right? Huh? Formulas actually, right? Formulas, we spelled formulas, huh? Structural formulas, those things. Crude oil means you are basically learning about extraction, petrol, diesel, likewise. So petrol, diesel, and extraction. Fractional distillation. Alkanes and alkenes are basically saturated and unsaturated. This is how you make a short notes, right? Alcohol is what? Basically alcohol containing OH groups. Carboxylic acid means it contains this. Esters means combining carboxylic acid and alcohol, you get the ester. Esters contain this. I show you one, you have got one wrong. But remember, if you have a plan on studying science, mainly chemistry or medicine or whatever, Yeah, you must know your chemistry. So after exam day, you can't forget stuff. Now you had your single lower. Next day you can't forget these things. You are learning these forever, right? Otherwise you are in trouble. Let's say you are doing your O levels, then after that, no one will reteach these, right? At the A levels. So you can't forget it after exam. You can't. You are studying. Okay, exam is there. Single award. Right. After that, you can't. No one is going to reteach you these things. After O levels, also same. Right. After A levels is also same. No one will teach you at the university again these chemistry. So you must know your stuff and go. So you may have a better mark in exam. You'll have a A in your O levels, A in your A levels, but if you can't remember what you learned before exam and after that time you are forgetting it, then when you are doing your degree one day, when you are doing your job one day, if it is science related, you are in trouble. You will struggle, right? So you must keep it in your head, permanent memory. The short-term memory is fine, perfect, but you must put that into long-term memory. So practice and live with it. So let's move on. So now we are moving under the moving under. We are learning under organic chemistry. So here we are in the introduction. Under introduction, we are learning about. Tell me. Yeah, we are still first learning about what are organic compounds. We should know that. We are learning about organic compounds. What are they? Because this is the introduction. We will believe you know nothing about organic chemistry, right? Okay. Oh, what are organic compounds? Then naming, right? Next thing, naming. Naming organic compounds, right? After that, make them classifying organic compounds. Classifying organic compounds. Okay, right. So under organic compound, now you tell me the definition before I tell you. Organic. What is an organic compound? Is that organic compound? No, no, no. You are telling lies now. Is that organic compound? No. What is an organic compound? No. Uh, Compound containing carbon except few compounds that are carbonates. Write the definition and send it to me, please. Carbonates. What else? Can you write and send me a picture? I am doing for your own good, right? You must know it now. Otherwise, So organic compound means compounds containing carbon. Except these are exceptions. We are learning about carbonates, carbon dioxide, carbon monoxide. Right? So they won't ask you why carbonates, carbon dioxide, and carbon monoxide and bicarbonates are not studied under organic chemistry. They will not ask you, but I will tell you the reason because when you look at the structure, they don't have a carbon directly attached to the hydrogen. Right? Don't write this in the exam, right? For your knowledge only. So basically, everything containing carbon except these. Then after under organic compounds, there's a special branch in organic chemistry. What is that we learned? The special kind of organic compound, hydrocarbons. Right? Write and send me what is hydrocarbon. Write the definition and send me. Very good. Contains only carbon and hydrogen. Only carbon and hydrogen. So this definition is very vital because we are again learning about hydrocarbons and the alkanes and alkenes. Right. Now we should learn how to represent. Right. So anyway, we go symbols. Right. So under representing organic molecules, because these organic molecules are much larger, right? But so with numbers and with letters only will not be enough, right? When you are writing a thesis or when you are writing an article, right? When you are teaching someone on the board, right? Just like other compounds, writing with the symbols, letters, and numbers will not be enough because these are huge structures, right? So they are under organic chemistry. We have to learn there are few ways of representing. So subtopic representing organic molecules. Organic molecules. Representing organic molecules. So what are those ways of representing organic molecules? Very good. So you can start off with even in inorganic chemistry we are learning this empirical formula. What is empirical formula? That's ratio, right? Empirical formula, formulae plural, molecular formulae, the exact number of carbons and hydrogens in a compound. Just the number, exact number. General formulae. Here this comes under only organic chemistry. What is general formula? Give an example. Very good. Especially in hydrocarbons, polymers, we must learn this. Structural formula. So what is okay? You learn. You do you know about discrete formulae? What's the difference between them? Structural formula is also sketched. It's a diagram. Displayed is also diagram. But what's the difference between them? Structure. Hmm. Is that the difference? In displayed, all the bonds are must be shown in displayed formula. In structural formula, we learned only we write only what the double bond between carbons, right? Double bond between carbons. So you must know that, right? And we have the displayed formula, and there's another was a condensed structural formula. The condensed version a little bit different than structural. Condensed structural formula. What is the difference between condensed and the structural formula? Yeah, what is shorter? If the carbon chain is has repeating units, so we repeat. Yeah, repeating units are we don't uh, draw the structure of the repeating unit. Instead of that, let's say if the CH2 is repeating 5 times in the main structure, we write what CH2 within the brackets. Let's say if it is 5 times, it's there. We write it as what 5 times. So therefore, we don't need to. Yeah, this is the difference. Write down the short note. This will be important for you. I'm making a short note actually, right? The comprehensive note is there in the book, the large one, right? With all the so this is the important thing for you, right? This is a difference. So these are the few things students are always because it looks similar now. Even for me also like structural form. Like it's about the structure. No, there's more than that, right? Because the difference only comes into play when you're learning about display. Then what's the difference between display and structural? What is the difference between the display, structural, and condense? Always compare, right? Argue yourself. Okay, why are we learning separately about another under another topic? There must be a reason. What's the difference between, right? And the displayed, right? Right. I'll give you since we have like you know about writing the names. Uh, I'll give you a question. Let's see whether you can write everything of them. I will tell. I will give the molecular formula. So other things you must decide, right? C4H10 molecular formula. You must give me the structures for all other. examples for this. This is the molecular, and you must label it, right? If you can remember mole- name in label, it, write the name, the formula name, right? And the structure. I write, okay, this is the displayed formula. This is the likewise label the structure, right? Now I labeled it. This is a molecular formula, right? Name was you said, right? Good. Butane. Go with the structures, right? Under now we have to do right part. One ID. Yeah, empirical formulae, general formulae, structural formulae, condensed structural formulae, displayed formulae. If you have any isomers, you can do isomers also. Isomers means if you can do the structure in another way, you know the difference between isomer. Yeah. If there are isomers, do the isomers also. Same molecular formula, different structural formula, isomers. Right? Other one, from display to structural. So how the atoms and atoms in a compound are connected to each other in space, and not in three-dimensional space, in 2D space, right? Right. And the next one, structural. Structural means we don't write any single bond. Carbon and to the right hand side, hydrogens. And again, carbon, hydrogens. Carbon, hydrogens. Then again, carbon and hydrogens. This is the structural, right? No bonds are mentioned. And then we moved on to what? Uh, Compact version, compact. You haven't sent it. What the compact for? Is it there with me? Condensed version. Right? The condensed version is what? There are two repeats, so we have condensed it. CH3, CH2, two times repeated, CH3. It's a condensed structural form, right? Uh, what else? Did we write? Did we finish off everything? Our general formula, general one is what we have here. So it's that this is the general CnH2 n plus 2. Where n means number of carbons in the structure. So this general formula can be applied to any hydrocarbon family. Hydrocarbon families are called, we learned, homologous series, right? Homologous series. So just like Pereiras and Fernandos, right? They also have families. Under families, they have many number of members, right? So all these, just like the surname, homologous series, it's like a surname. We write it at the end of the name, right? Since it's alkane, the name means as what? A in A. That's the name of the surname of the homologous series alkyl. Uh, right, I think we are done with that question. And the isomer, right? Yeah, I asked if you can remember what an isomer is. Roll my isomer. So it has what? One. You can connect the carbon to here also. Right? What is the definition of an isomer? If you can remember, structural or displaced form, right? Different structure, same molecular, same number of carbons and hydrogens and any other atom is there, but their connectivity is different. How they are connected to each other is different, right? Okay. Then shall we move on to organic terminology? And yes, organic terminology. What is meant by organic terminology? Organic terminology means naming, right? So most of you guys are now, even after with good practice, sometimes in the exam you are getting your answers wrong because you guys are forgetting your basics. When you are doing a sports also at the beginning, right? You are very humble and you are sticking with the basics. You are being very technical players. When you are playing basketball or cricket or football, you are technical. But when you become a star, when you become good at it, you forget your basics because the game becomes part of your instinct, right? But when you are in trouble, right, in a game, in exam, right, when you're in a tense moment, sometimes you lose your instinct, you lose your rhythm, right? So if you in that for in at that times you lose your instinct. The only way to come out of is your basics. But if you have forgotten your basics, then you are in trouble, right? The organic terminology is something like that. You got once you get the hang of it, with good practice, when you look at the structure, you write the name with instinct. That's okay, good. And when I give you the name, you can draw the structure with instinct, right? But in a tense exam, in exam situation, they're testing your knowledge, right? They know, okay, in some places you are getting stuck. So in that case, as you lose your instinct, then you forget everything. If you can't remember your basics, if you can remember your roots back, then you can come out of it at that moment. So that is why always remember the basic, right? So what is the basic? When you are learning how to name it, right? We are starting off with breaking the name into two parts. What are those two things? If you can remember in organic terminology, alkane, alkenes are not. These are about hydrocarbons. I am talking about the name is broken into two parts. Your surname and your front name. Front name tells you who you are, and the surname tells you your homologous series. When you're naming also, there are two parts, right? Prefix and suffix. Can you remember? Prefix and suffix. Suffix means later name, surname I would call it. Tell your family, right? By looking at the suffix, we can tell you, okay, whether you are Pereira, Fernando, whoever it is, right? Or your homologous series. It tells you whether you are alkane, alkene, carboxylic acid, whatever it is, right? Homologous series. Prefix tells you your identity. Amal, Kamal, whoever it is. Prefix, right? By combining them, we are coming up with the name. right? So suffix tells you surname. The homologous series prefix tells you mainly at your level. At your level, remember at all level levels, prefix means mainly number of carbons in the main chain. Right? We are adding few more. There are very complicated names also in ourselves, right? There are surnames, there are like complicated names. But we are not learning about that complications. At the very beginning, prefix tells you number of carbons in the main chain. Number of carbons in the main chain. Right? Later we can do some modifications, right? When the side chains are connected. This is the basic. Okay. Right. Another thing, now we came up with prefix and suffix. Prefix name tells you the number of carbons in the main chain. That is kind of understood. And we came up with another thing called homologous series. Now we should learn now what is a homologous series. Now we have studied it before, right? This is revision. Now, what is homologous series? With your own words, tell me. Ah, homologous. Very good. That's one of the similar chemical properties. Right. Why do they have similar, not the same? Same is identical. No, not identical properties. Similar. Right. Why do they contain similar chemical properties? Homologous series. Homologous series means family. Under this family, there are many members. Right. Let's start off. Homologous series. As you said, they have similar chemical properties. Similar chemical properties. Chemical properties comes based on you how they react. Based on the reaction, how they react. Chemical reactions. Chemical reactivity. So it means they have similar chemical reactivities on the same, right? Similar chemical reactivities. These are similar. Now remember, now we talk these organic compounds are very large, could be very large, but remember, even though these chemical compounds are very large sometimes even, their reactive parts are only a very specific part is reactive. Other parts are kind of mainly inert. You can make them reactive with extreme conditions, but usually the most reactive parts, most sensitive parts are, for example, there are several group of compounds connected to this main chain. That part is reactive actually. There's a reactive part. This is the part chemical reactive name mostly. A reactive part, right? Since they are reactive, we call it as what? Functional group. This is a functional part. The chemical properties based on this part. Functional groups. That is why we call them functional groups. Chemically reactive. Other parts are relatively inert. This other lone parts. There can be several functional groups. Other parts are relatively weaker. They are inert, non-reactive, relatively, right? So in homologous series, right, they have the same functional group. Same functional group means their chemical properties are going to be similar. Even though their non-reactive parts are different, their non-reactive parts are different. We don't mind. There can be like this, but still they have similar reactive part. See, shorter, longer, branched, we don't mind. See, their reactive part is the same. Functional groups are the same. This is the chemical reactive part. Right? How whole compound chemical response depends on this functional group. So if the functional groups are the same, their chemical reactivities are also similar, right? They have similar chemical properties. Why? Then tell me why. They have what their technical term. They are the same functional group, right? You must use the specific term, right? Because they have the same functional group, not the similar here, right? Same. Similar properties, chemical properties due to the same functional group. They have the same functional group. Right? That is the reason. So see how nice it is now, other than memorizing this stuff as a parrot, right? But here's the catch. Now the chemical properties are similar and the same homologous series. When you talk about Pereiras, their chemical properties are similar. But the physical appearances are different. When you look at a family, they are different from each other. They are males, females, taller, shorter, black, white. Likewise, what can you tell about the physical properties? Most of the time, students are getting this wrong. Chemical properties are similar. What about the their physical properties? Yeah. What about their physical properties? Are they the same or different? Ah, why? Why? The same functional group that has nothing to do with the physical properties. It only with the chemical properties. Different physical properties. Why? What is meant by physical properties? Chemical properties means chemical reactivity. Chemical reactivity means how electrons change. Yeah. Example. Let's say melting point and boiling point. What is melting point and boiling point? Okay, now I'll give you some examples. You tell me on the same homologous series, alkanes. I'll give you two alkanes, methane, ethane, and propane. Write the names. If you can remember how to write the name, full names. I want you to arrange them in order. They are boiling point and melting point with their names. Which one is having the higher boiling point and lower boiling point with their names. and tell which one of these are having the strongest intermolecular interactions. Right? Intermolecular interactions. You know about intermolecular interactions, right? Why? Why? Okay, then. Okay. One thing to add on, when the molecule is larger, automatically number of electrons. Now, if you count the number of electrons between these three structures, which structure is having more electrons? When the structure is larger, more atoms means more electrons, right? More atoms, each and every atom added, right? It has more atoms. This third one, more atoms, so it has more electrons, right? Okay, let's write. Okay, as you said, melting point and boiling point increases. Melting point and boiling point increases. Why do they increase? Intermolecular interactions are getting stronger, so you need more energy to break them. Since intermolecular interactions are getting stronger. Stronger. You need more energy or more heat to break them. Heat, temperature needed to break them. Okay. So why intermolecular reactions are getting stronger? When larger molecules, it has more electrons. Larger compounds means it contains more atoms. More atoms means what? More electrons. More electron cloud, we say. More electron cloud means more intermolecular interactions. Right? So their physical properties are what? Uh, Changing in an order. Right? Change as an order in the same homologous series. What do we call this? Change of physical properties in an order, uh, which each carbon atom. Yes, we call it as gradation of physical properties. Whole gradation of physical. Can you remember physical properties? It's called gradation of physical properties. Grading. Now this happens. We can tell gradation of physical properties with each CH2 added. Right? With each CH2 added in. Right? So next to each other, if you look at here, see, from methane to ethane to propane, what do you see? A new CH2 has been added. So therefore, with each CH2 added, that's the only difference, right? Having one more CH2, see, compared to each other. So gradation with each CH2 added, more atoms. More atoms means more electrons. More electrons means more intermolecular interactions. Specifically, you are learning in A levels what these interactions are. We called London forces, London dispersion forces, right? So, under intermolecular interactions also, we are categorizing them under several groups. Hydrogen bondings, uh, IDID, in this dipole, instantaneous dipole interactions, London dispersion forces, right? Likewise, we are dividing it under many categories. But here you just need to tell intermolecular interactions, right? So how with the number of electrons, intermolecular interactions are getting stronger, you are learning that in the A levels, right? So knowing up to here is more than enough. Okay. Uh, right now again, now there are several functional groups you need to learn as an O levels child. Six functional groups, right? Six functional groups means you should know how many homologous series. Okay. Okay. More electrons, electron clouds, right? They call them clouds. Good one. Since you asked me, I'll tell you. So some things what I'm telling you may be harder for you to comprehend. So sometimes even for what do you say, international syllabus students, you don't teach this even for A-level students. But actually, we call them, they are the electrons are as a shell. Now learn this and then forget it, right? So these electrons are as shells. No? Now remember, electrons never orbit around like this. Now, so that is called classical physics. Classical physics means Newtonian physics. Our galaxies, in our galaxy, we have a sun. Around the sun, planets are orbiting around. Just like that, we teach you in the middle school and in O levels, and even for A level students, those who are doing international syllabuses, these electrons are orbiting around. But remember, these atoms, these electrons are very small, so we cannot explain the behavior of these electrons and atoms from the physics of chemistry means physics, no? Physics of we call Newtonian physics, classical physics. So to explain this, we need something else called quantum mechanics. So under quantum mechanics, we don't tell these are orbiting around, right? So we just tell we can find the electron around here. Sometimes what I am going to tell you is not will not for you may be harder to comprehend. There's a probability for you to find an electron around here. Just a probability. If you try to find an electron, you will find them around here. That's it. It is not orbiting around. You may find an electron. We can't tell you where it is, but there's a probability for you to find an electron around here. That's it. Two electrons, right? So it is actually we call it a probability cloud. It's like a cloud. So in near the shell, you have more chance of finding it, right? When you go away from the shell, in between the shells, there's a less chance of finding electrons, right? So what we call shell is not actual shell. Around this area, there's a higher probability of finding electrons, just like a cloud. Actually, these electrons are disappearing and appearing. Okay, what I'm telling you is kind of crazy. Electrons are appearing and disappearing, right? Quantum mechanical phenomena, appearing and disappearing, just like a wave. Neither a wave, neither a particle.